Hello, welcome to the video notes for lesson 12-6. These notes begin on page 33 in your notes packet. Let's go ahead and get started. So, this lesson is all about problem solving. And remember, this topic is all about the Pythagorean theorem, so we're going to be using the Pythagorean theorem for problem solving. Alright, so the learning target for this lesson, I can use the Pythagorean theorem to find, I think that should say to find and solve problems. Alright, so our first example on page 33 is a word problem. A contractor is designing a roof of a garage. The height of the roof is 4 feet. The slant of the roof, or hypotenuse, is 5 feet. What is the length of the garage? Now, actually I'm going to move the screen up so I can have some workspace. So, we need to find the length of the garage. Here, they have already taken the, done the job of identifying the height for us, which is right here, and it's 4, we know that that's 4 feet. If the hypotenuse is 5 feet, now that means that's going to be a line that's extending this way or a line that's extending this way. Think about what a roof looks like. That's going to be 5 feet. So we want to find the length of the garage. That's this distance down here, whatever it may be. Now, if the hypotenuse is 5 feet and one of the legs is 4 feet, hopefully you know what that is telling us. Essentially we have a squared plus b squared equals c squared. I'll call the 4 feet a, and the hypotenuse we know is c. So I have 4 squared plus b squared equals 5 squared. Hopefully many of you have already figured out what b is going to be. So 16 plus some number equals 25. Subtract 16 from both sides, and you get b squared equals 9. So b equals 3. So this distance down here, now be careful, is going to be 3 on one side of this leg and 3 on the other side. So count 3 spaces over. 1, 2, 3. Put a dot. Count 3 spaces over the other way. 1, 2, 3, and put a dot. Now we just simply connect the top of our roof down to that dot. And let's go ahead and label our parts. So this is 5 feet, the slant height, 5 feet. And then this is 3 feet, and this is 3 feet. So let's go back up to our question. What is the length of the garage? The height of the roof is 4 feet. The slant height of the roof is 5 feet. The length of the garage is this distance here. So we add those two numbers. The length of the garage is 6 feet. And it's so nice that it worked out to be a nice perfect square. Alright, so that's the first example. I'm going to clear the screen, so pause the video if you're not done. And I'm going to turn to page 34. How does this work with the coordinate plane? Alright, so this is probably the most tricky part of using the Pythagorean theorem. So make sure you pay attention and practice what we're about to do. Point B has the coordinates 1, 5. So I'm going to go on my graph and 1, 2, 3, 4. Put point B. The y-coordinate of point A is -3. So when I think of x and y is going up and down. So I go down to -3. Now I'm not going to put a point there. That means that point A is somewhere along this line, because this line here, going from side to side, has y values of -3. So somewhere along this line is point A. It could be on this side, it could be on this side. Now, the distance between A and B is 10. This is our hypotenuse. which means when they tell us that it's 10 units, C equals 10. Now, this point B here is some distance away from where A is going to be, which is this line here, y equals -3. I can count the number of spaces here, and it's 8. That I'm going to make A from my Pythagorean theorem. So I have two sides, A and C, so now I just need to find B. Pretty simple, right? So A squared plus B squared equals C squared. So A is 8, B we don't know, C is 10. So 64 plus some number equals 100. Subtract 64. B squared equals 36, which means B equals 6. Now, I have the distance for the other leg. So I start down here at this point. This is where my right angles are. So if I go this way, I count 6 spaces, 1, 2, 3, 4, 5, 6, and put a point. So this could be point A. Or I could have a right triangle going the other way. So I count 6 spaces going the other way. 1, 2, 3, 4, 5, 6. Notice the question says, what are the possible coordinates of point A? And there's two possibilities. So I'm going to connect B to this one and B to this one. Essentially, I have the same right triangle, just facing a different way. So A could be this point or this point. So the possible coordinates of point A, are, and we have, I'll go to the one on the left here. If I count over, it's -5 and then -3. So one possibility is -5, -3. Notice the y value is -3, just like it says in the problem. Or, if I go the other way, that's 7, -3. Or 7, -3. And that's it. That's how you answer this type of problem. Alright, I'm going to clear the screen, so if you need to copy more down, pause the video. Alright, point B has coordinates 5, -2. We're going to do one more problem like this, and then you're going to try practicing this. You need to practice this type of problem. It can be a challenge if you don't practice. Alright, so point B has coordinates 5, -2. So I count over 5, 1, 2, 3, 4, 5, down 2, put a point. There's point B. The x-coordinate of point A, so this time we're given the x-coordinate, not the y. So last time we went down 3. This time we're going to the left 7. And this is where x is -7. All along this line here, going up and down. So the distance between point A and B is 13. Remember what that is? That's the hypotenuse. What are the possible coordinates of point A? So what we need to do is figure out the leg that we have. That's this distance here. And if you count the spaces, you find that it's 12. So I'm going to let A equal 12. So it's 12 spaces from this line to B. So A squared plus B squared equals C squared. A is 12. B we don't know. C is 13. 12 squared is 144. 13 squared, 169. Subtract 144 from both sides. And B squared equals 25, which means B equals 5. So I have my other leg. This is not my final answer. So along this line, I need to count 5 spaces either direction. So 1, 2, 3, 4, 5, put a dot. So this could be B, or going the other way. So here's my right angle in this corner and this corner. 1, 2, 3, 4, 5, put a point. And what I usually do is draw an arrow going both directions and put the word or. So B could be this point or this point. Now, if I use my straight line tool and connect it, you should have a better sense of the possible right triangles. They are identical, they're just facing different directions. So let's answer the question, what are the possible coordinates of point A? Oops, I bet some of you noticed I made a mistake all along. It's A. The possible coordinates of point A are, so one possibility is -7, 3. That's the A up top. And then the A down here at the bottom is -7, -7. Or -7, -7. Alright, so a lot of stuff involved with this one, but it is not impossible, and it works out actually pretty nice once you practice it a little bit. So the other part of your homework is page 35. There's 2 more questions, just like ones we've already answered with the key at the bottom. So you need to practice this to know if you got it yet. If you have any trouble or you are confused, go back and rewatch the video or come see me for help. Good luck, and we'll see you in math.